This is the luckiest maths teacher in the world. Thank you so much for tuning into this video on multi-stage events. As the name suggests, we're talking about events that occur in stages, and specifically we will look at tools that help us write down all of the possible outcomes, and we will use this to calculate probabilities of multi-stage events. So previously we've looked at Venn diagrams and two-way tables. So they're all about finding the probability that something is in one set or both sets or whatever, not for multi-stage events. So let's go ahead and look at an example. So let's do this question here. A die is rolled and a coin tossed. What's the probability I get tails and an even number, tails or an even number, tails or an even number, but not both? So to answer all of these questions, what we want to first do is come up with the sample space. Recall that's the list of all the possible outcomes. So I'm going to show you two tools to do this in this video by using tables or tree diagrams. So for this example, I'm going to use a table. So this is a multi-stage event. The two stages are first rolling the die and second tossing the coin. So what we're going to do is write the outcomes of the first stage along here. So for rolling a die, I could get a 1, 2, 3, 4, 5, or 6. That's the first stage. And the second stage, I could get heads or tails. So these are the possible outcomes. I'll just put H1 to mean I got heads and rolled a 1, and H2 for heads and rolled a 2, and then T1 means tails and rolled a 1, tails and rolled a 2, and so on. So each of those blue things represents one possible outcome. So you can see that there are 12 possible outcomes. So once we've got these lists, these questions here become really simple. It's just a matter of counting. So for the first one, tails and an even number, we just go to our table and we find all the ones that have both tails and an even number. Well, this one has tails and an even number, so does this one and this one. There are 3 such outcomes, 3 ways that I could get tails and an even number, and there are 12 outcomes in total. So it's 3 over 12 or a quarter. First one done. So now let's look at examples that involve tails or an even number. So by now, you should know that when we say or in probability, we mean one, the other, or both. I want to include all of the ones that are tails, all of the ones that have an even number, and all the ones that are both. So this outcome here, that's included because it's an even number. It satisfies the second part of this even number. So I include this one, and this one because they're all even numbers, and I include all of these ones here because they are tails. So hopefully you can see that I have counted 9 possibilities. 3 of them on the top row of our table, 1, 2, 3, and then 6 on the bottom row of the table. There are 9 outcomes in total, so the total possibility is 9 over 12, or in this case, 3 quarters. So what about this last one? Tails or an even number, but not both. So I want to include most of the ones I just said. So I want to include this one, and this one still, because they're even numbers, but they don't have a tail and an even number. I want to include this one, because it's tails, but it's not tails and an even number. I don't want to include this one anymore, because it's tails and an even number. It is both. So too, this one is both, and this one is both. So I don't want to include this one, or this one. So the ones I want to include 1, 2, 3, 4, 5, 6. All those with a green mark in them are tails or an even number, but not both. So you can see there are 6 possibilities out of 12 possible outcomes, so it's 6 over 12 or a half. Now, each of these 3 things would have been hard to calculate without the table. So that's all the table does, helps us list the outcomes and makes probability calculations that much easier. All right, now I'm going to show you another way you can list outcomes, which is through a tree diagram. So please pause and copy this down if you need. So let's look at this question here. So Mr. Luck has a bag of chocolates, has a Mars bar, Boost, and Crunchy. So Star Student Will, that one is always in a good mood, always makes me smile. He will pick a chocolate from that bag at random. Whichever one he picks, it will be replaced. Then he'll pick a second one. We're going to find the probability he picks a Mars bar. So this is a multi-stage event. The two stages are the first chocolate that's picked and the second chocolate that is picked. So this is not an obvious question. What is the probability that he picks a Mars bar? It's not obvious just from the information. But what we're going to do is we're going to list all of the possible outcomes, and then this question will be easier. So to list all of the possible outcomes, this time we're going to use a tree diagram. So we set up the tree diagram like this. So I'm just going to put first and second. So that means first stage and second stage. So first stage means the first pick of the chocolate. So then you list all the possible outcomes below that. So I've got possibility Mars bar, Boost, or Crunchy. So the second time Will picks a chocolate, he can also get a Mars bar the second time, because I said it would be replaced. So if he picks a Mars bar first time, it's replaced with another Mars bar. He can get a Boost or he can get a Crunchy. Similarly, if he gets a Boost first go, he can get a Mars bar, Boost, or Crunchy. And if he gets a Crunchy first go, second go, he can get a Mars bar, Boost, or Crunchy. So now we're going to list all of the possible outcomes by following the tree. So we've got 2 Mars bars, Mars bar Boost, Mars bar Crunchy, and so on. So you'll see that there are 9 possible outcomes. There were 3 outcomes the first go, 3 outcomes the second go, 3 times 3 is 9. So all of these are equally likely to occur, so the probability of any one of them is 1/9. So we know they're equally likely to occur because there were the same number of Mars bars, Boosts, and Crunchies in the bag each time. There was 1 of each. So for example, the probability of getting 2 Mars bars is 1/9. So what's the probability he picks a Mars bar? So once we've listed the outcomes, this is easy. We simply need to count the ones which satisfy what we're interested in. We're interested in outcomes that have a Mars bar. So let's count the ones that have a Mars bar. So this first one here, yes, it has 2 Mars bars, but we include it because that will mean he will get to eat a Mars bar. So the first one counts. That has a Mars bar. This one has a Mars bar. This one does. So does this one, but this one doesn't. This one doesn't, doesn't. So if we go through and look at the ones that have a Mars bar, we're talking about these first 4 all have a Mars bar, and then there's another one here. So, the probability that he gets a Mars bar, there are 5 ways this can happen out of 9 total outcomes. That's the answer to our question. The probability that he gets a Mars bar is 5/9. Again, that would have been really hard to find if we didn't have this tree diagram. Alright, thank you so much for watching this video. First 5 people to say Caramello Koala and mention this example in the video, you will get a Caramello Koala. This has been the luckiest maths teacher in the world. Have a great day.